Hello, ladies and gentlemen of geometry. Let's go ahead and get started on this problem. It's number 2 on your quiz. It was the first on the skill page, and you're asked to find the distance between A and B if A and B were defined like this. So Michaela Moroni is not impressed. If you get the joke, that's awesome. If not, not a big deal. So why did I pick this picture? Why am I saying she is not impressed by the work? It's pretty simple, because the mistakes that we saw consistently made were mistakes that were just silly. We don't really know Mr. Martinite. If it was just a lack of knowledge, maybe he's being a little bit lazy. Maybe there's a misunderstanding of how important some of the kind of fundamentals of mathematics, especially the fundamentals how to work geometry problems, have actually now really started to affect our work. The fact of the matter is, it's starting to. So one thing we're going to definitely talk about as we're talking through this problem is some of the lack of precision that we saw in the problem. So right now I'm going to go ahead and excuse Michaela. Delete. And let's talk about this. So you're asked to find the distance. So, I mean, you can approach this a couple different ways. One way is to simply acknowledge that there is a distance formula where the distance AB can be calculated as a derivation of the Pythagorean theorem, aka distance formula, where we're just taking the difference in the x's and squaring it and adding to the difference of the y's and squaring that, in the same way that you take like a squared plus b squared, that's equal to c squared. I did give you, or we did talk through an alternative version of the formula, which is delta x squared plus delta y squared. And really it's the same thing, because if you remember our conversations about how to find distance over a plane, horizontal distance, change in x, vertical distance, change in y. So if you choose to go this route, which is not a bad route to take, because like I said, this is a pretty straightforward skill-based kind of problem, I'd encourage you to use one of these two forms, whichever one makes the most sense in your head. Now, if you're going to use this first form, it was not a bad idea to go through and actually identify what's what. In this case, let's call that one x1, y1, for no other reason because I arbitrarily chose it. Arbitrary means I just wanted to, so I did, because the order doesn't matter, because we are eventually squaring this. And let's make that x2 comma y2. Alright, so jumping into this first version, let's go ahead and just use kind of this guy right here to speed the process up. It's really a matter of plugging in the pieces and then solving the algebra. And here's where a lot of the imprecision, a lot of the kind of mistakes we saw started cropping up right away. So getting into the problem, if we go ahead and replace the values x1, y1, x2, y2 in our formula, I'm going to make it pretty big to give us some room. x1 minus x2 is going to amount to 5 minus 10. Now, look how I'm going to do this, guys. I'm going to use parentheses. Just because I'm just doing a replacement. I'm not trying to do any of the math as we go, so to speak. I'm not going to try to simplify as we're writing it down. I'm just simply going to transfer. So I have 5 and I have a negative 10. So I have 5, a minus from that minus right here in the problem, and then a negative 10 for that value right there of negative 10. We'll square it. I'm going to add that to the y minus y1 squared value. So y1 is negative 10, y2 is 6. Again, I'm just going to put in parentheses because I'm not trying to solve this as we go. I'm just going to write it down first, and then we'll do some simplification. That is where one big group of people who made mistakes can be categorized. Some people didn't use parentheses here. As a result, they really got hurt in the next step. Let me demonstrate why. So if we're just going to do a round of simplification, 10 minus 5, minus a negative 10 is going to be a 15, and that'll be squared, plus negative 10 minus 6 will be a negative 16 squared. Okay, so when we talk, doesn't mean just break a few seconds and we talk about why parentheses are so important here. A lot of people didn't put them. So here's what happened, and please don't write this next part down. I'm simply going to demonstrate the mistakes I was seeing made. If I were to take away these parentheses, okay, even if you managed to avoid simply squaring only the 6, this became negative 16 squared, written like this. These two values, this value and this value, are not the same. In fact, they're precisely opposites of one another. This down here, the way it should be written, says take negative 16 times a negative 16, i.e. the result is a positive number. Here it says take 16 squared and then make it negative. So if you were just to use a calculator to do this, again, to demonstrate, which I know for a fact you've seen this demonstrated before, so I don't know, again, if it was lack of knowledge, being stubborn, or just being lazy. If I type in negative 16 and then I square it, I end up with negative 256. If I type in negative 16 with parentheses, and then I square it, I get 256. Drastically different numbers. So yes, it does matter a lot. Yeah, you need to use parentheses, especially if you're using this form of the formula, the one that we're currently using. Please don't be lazy on that. Please use parentheses. Please put these in here. It has made a huge difference between people who got it right and people who got it wrong, and that's a simple fix. So as we're continuing here, another huge problem cropped up that we can talk about. This square root does not, this square root does not cancel out these two squares. The square root cancels a square under a single term. So if I simply had 15 squared and then I square rooted it, yeah, this square root would kill this square. But the rules change drastically if I have a multi-termed expression under the square root. So in other words, if I have two things, like if I have 2 squared plus 3 squared, this is not going to be 2 plus 3. Right? It's not. In fact, we can prove it by simply working it out. 2 plus 3 is 5, right? 2 squared is 4. 3 squared is 9. So the square root of 13 is not 5. So the square root does not cancel these two squares if you have a multi-termed expression under the square root. That's not the way it works. So it doesn't work the same over here either. And again, the biggest kind of thing I saw where we saw kind of committed as a mistake in this problem is that this just became 15 plus 16 or 15 minus 16. None of those are correct. So if you're making that mistake, correct it now. It's a simple algebraic rule that you have to follow. In other words, you have to work from the inside out, square the terms, and then take the square root of the result. So square root has not been solved yet. That's going to actually stay right there. We can go ahead and solve these two squares. 15 squared, I believe, is 225. But let's go ahead and check to make sure we're okay. So 15 squared is 225. 16 squared, or negative 16 squared in this case, is going to be 256. Okay? So we'll continue here. We're looking at the square root of 225 plus 256. So looking at the square root of 481. Now, if you left your answer like this in unsimplified square root form, I would have taken it. If we want to go ahead and simplify it, I do ask you to go to 4 decimal places. So the rounded answer of this would be 21.9317. So either one of these two answers are acceptable for this first problem. Okay. I do want to kind of mention in the same kind of token, there is another way to do this. And when I say another way, I just mean kind of using this formula. It involves a little bit of logic, but it is one that can actually work out. I'm going to demonstrate that. I'm going to try to demonstrate that, as quickly as possible here. Let's see, eraser. Okay. So change in y, change in x. I mean, we're just talking distance. So if you can kind of calculate what the distance is on the fly, you can certainly use the second form of this equation in a more shortcutted manner. So if I look at the distance of AB as being the square root of the change in x squared plus a change in y squared, I can probably look at those distances, change in x, change in y, pretty quickly. So change in x, if I'm starting at 5 and ending up at a negative 10, that's a total linear distance of 15. So, I mean, if I think about a graph or maybe a number line, 5 is here, negative 10 is here. It's going to take me 5 to get to here, another 10 to get to there. That's a total of 15, hence 15 squared. I can think of the y's the same way. If I start at a negative 10 and end up at a 6, that's a total distance of 16. Hence 16 squared. It doesn't give me a different answer, it just gives me a different way to arrive there. And again, it takes a little bit more thought, it's a little bit more finesse, but this definitely will work just as easy, just as quick, given that you can calculate those distances in your head pretty fast. So again, this would be what, 481, which is the same approximate distance as 21.9317. So either methodology will work. Okay? Let's go ahead and jump right to number 3. Now, the only difference here is that I'm using kind of more difficult numbers to be really honest, to force you to kind of use that first formula. But again, the big step here is kind of identifying what you're looking at. Okay. So you're looking at this distance JF. We can look at it as x1 minus x2, square it, plus y1 minus y2, square it. And that just becomes an issue of replacement. This is a pure algebra problem. That's why I was under the skill page. Again, we're going to use parentheses. X1 will be negative 3.25. Subtract comes from the formula. X2 is going to be 10.3. And we'll add it to the y1 minus y2 squared. So we have 6.75. Subtract off a negative 8.62. I did see a couple people kind of ignore the second negative here, just make it one negative. You guys can't do that. One negative comes from the formula, one comes from the number. Both need to be represented. Okay, so correcting this, or I'm sorry, I shouldn't say correcting, but simplifying this. First, we'll actually do the calculation in the parentheses. So negative 3.25, and we'll subtract off 10.3. So that gives me a negative 13.55, and I'll be squaring in the next step. Here we have 6.75. And we're going to add, because two negatives make a positive, of course, 8.62. And that'll give me 15.37. Again, we're going to square it. So if I square 15.37, I'll end up with 236.2369. And if I square 13.55, I'll end up with 183.6025. Okay, so add those together. And then take the square roots. I should end up with an approximate answer of 20 point, and again, let's round here. So this kicks up that 9. So that kicks it up, so it'll be 20.4900. Okay, so again, I hope this helped. We'll be looking at the next couple of problems in the next couple of videos. So I will see you then.